This is a problem involving the Arrhenius equation. We're comparing the rate constants obtained at two different temperatures and asked to calculate the activation energy EA. This is not the most accurate way of doing it. There's only 2 points. What would be preferred is if there were more than 2 points and you do a graphical solution. But here we have 2 points, and we can arrive at an estimation for the activation energy. We have applied our 2-point Arrhenius equation and solved for EA. So what we need to do is be careful to make sure that we're keeping straight condition 2 from condition 1. And we just plug and chug. Alright, so once we have it set up, it's just an calculator skill exercise. Note we have to use the value of R in joules per mole since we're dealing with energy rather than moles and volumes of gases. So we're going to use 8.314 joules per mole K. We crunch this out. We can only justify 2 sig figs. So we round this off to 2 sig figs. We go from joules per mole, divide by 1,000 to get 2 kilojoules per mole. For part B, we're calculating the rate constant K at a third temperature. We'll call this condition 3. 35 degrees C is equivalent to 308.15 K. And we will be solving for K3, the rate constant at 308.15 K. Here the equation is set up to solve for ln of K3. We did use the property of logs that ln of A over B equals ln of A minus ln of B in order to expand this term. So now we can just plug in our numbers and chug out a numerical answer for ln of K3. Alright, and here we are with a numerical value for ln of K3. It's going to be minus 8.846. And here we are with our final answer. K3 is 1.4 times 10 to the minus 4. And finally, part C, we want to calculate the numerical value of the pre-exponential factor A, which is related to the number of effective collisions per second. We start with the Arrhenius equation, and we're going to be solving for A, and we can choose any one of these 3 temperatures and their corresponding value of K in order to determine the pre-exponential factor A. And here we are at our final answer. We churn out our numbers carefully on our calculator, and we find that A, our pre-exponential factor, is 5.6 times 10 to the 13th effective collisions per second.